Mr. 4.0. Today, I'm going to teach you how to use calculus, and I'm going to teach you how to use the product rule. Today, we're filming inside the gym because sometimes calculus happens outside the classroom. Today, I have a few whiteboards here, and I'm basically going to walk you through how to do each step to complete a complex function using the chain rule. The first thing we want to do is find our function. Our function says that f of x equals t to the fifth power, the square root of 3 plus 2. Fair enough? Okay, the first thing that we want to do is, first step, rewrite the function without the square root. And this is how it's going to look. We want to say f of x is equal to t to the fifth power, and the only way to get a square root out of a function is to multiply it by 1/2. It's going to look like this. T cubed plus 2 to the 1/2 power. Now that we have our function in polynomial form, the next step is to identify f and g of x. It's going to look something like this. And I'll show you over on the big board. I want to call the first part of my function, f of x, and the second part of my function, here, g of x. Now that we have identified both parts of our function as f and g of x, we can go on to find the derivative of both parts. F of x is equal to t to the fifth power, and g of x is equal to 3, sorry about that, t cubed plus 2 to the 1/2 power. Now we're finding the derivatives. If you've never found derivatives before, it's going to look something like this. Very simple process. Say you have, this is an example, say you have a number, 2, and you have a x, and you have an exponential value of 4. That's 2x to the 4th power. The easiest way, the most common way to find a derivative would be to, it's a trick, would be to take 4, times it by 2, take 4, multiply it by 2, and that equals 4 times 2 equals 8. Keep your x, and minus your exponential value here, 4 by 1. You're going to get 8x to the 3rd power. And this works for finding the derivative, basically, of any exponential function. You'll know that your answer is right when the power of your function, or your exponential value, decreases by 1. See here you had 2x to the 4th power, it decreased by 1 degree, and you have 8x to the 3rd power. I'm going to get rid of this example. So finding f prime of x would equal to t to the 5th power. Now let's find the derivative. 5 times 1, we all know that there's an invisible 1 here, would give us 5t minus 1, which is 4. So f prime of x equals 5t to the 4th power. Now we have to do the same step for g prime of x. Let's refer over to our step board. Our step board, after identifying f and g of x, we want to find the derivatives of f and g of x. We're doing that right now. The derivative of 3t cubed plus 2 to the 1/2 power. Simple enough, but there's also a trick to it. We have to use the 1/2 power as our exponential value. So when you multiply 1/2 by 1, 1/2 you can't multiply it by that, so it's going to look like this. It's going to be the same thing. Only thing that's going to flip is going to be negative 1/2 on the other side. I'll show you. Give you a clear example. We have our 1/2 power there. We take our 1/2 power, multiply it by 1. It's going to come out to negative 1/2. And then we keep our brackets and we put everything back. T cubed plus 2. And for clearer reference, I like to keep the negative 1/2 power in the back. And it's going to look just like that. Negative 1/2 power. Now that we have g prime of x, t cubed plus 2 to the negative 1/2 power, we have all of our functions in line. The fourth and final step is to put each part of the function into the chain rule. And the chain rule states that g prime of x times f of x plus g of x times f prime of x should give us an answer to our function. And when you find the answer to a function using calculus, you find the slope of any curve at any point. I'm going to give you a brief example. Say this is our graph and this is our curve. It's doing some stuff like this. It's hypothetically speaking. It's not a real curve. It's doing some stuff like that. Blah, 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 blah. So, finding f of x times g prime of x times f of x plus g of x times f of x will give us a point anywhere on this curve that we want. We can find any point on this curve, and what we can find is the tangent line of those points. All right? So, we're going to plug in each part of our function into our chain rule, and we have g prime of x equals to t cubed plus 2 to the negative 1/2 power f of x times multiplied by f of x, which is 5t to the 5th power plus g of x, which is t cubed. Oh, sorry, I made a mistake. Excuse me. Small mistake, but that's why we have a erasing board to fix it. G of x equals to 3t to the second power times 2. Oh my God, I messed up. Get it out.